Assalamualaikum warahmatullahi wabarakatuh. Good morning and guten morgen to everyone. Today, on the 5th of August 2021, I would like to first welcome everyone to our webinar session titled Industrial Robotics Arm Application in Industries. This webinar session is organized by Malaysia Productivity Corporation, MPC, in collaboration with German-Malaysian Institute, GMI, and the support of co-partners Malaysia Automotive Robotics and IoT Institute, MARii, and CuberLab Sdn Bhd. My name is Fahrul Rizal bin Halim, Head of Marketing and Corporate Communication Section, German-Malaysian Institute, GMI, and with us today, our esteemed speakers, specialists in robotics and IoT team, CuberLab Sdn Bhd, as well as founders of Delta Global Automation Sdn Bhd, Mr. Shafeek Ahmad Mustafa, and Mr. S. Yuvarajoo. Both of our speakers today are certified HRDF trainer with more than 8 years technical and professional experience in industry and corporate training. Having professional certification in CSWP SolidWorks Professional, Scala Robot in Universal Robot, Epson and ABB, microcontroller-based automation, industrial automation and machine design, graduated from University Technology Malaysia with Master of Philosophy and Engineering. Mr. Shafeek Ahmad Mustafa is an expert trainer in industrial robotics, PLC, machine vision, IoT, Arduino, smart system, and many more. Mr. Shafeek is our first speaker for today's webinar. Assalamualaikum and good morning, Mr. Shafeek. How are you?
Walaikum salam and good morning. Thank you. I'm fine. Good.
Yeah, thank you. Thank you, Mr. Shafeek. Alhamdulillah. Equipped with TTT certificate on Universal Robot, Basic Training ABB Robotics, Training Certificate Universal Robot Service and Troubleshooting Certificate. Also graduated from University Technology Malaysia with Master of Philosophy. Mr. S. Yuvarajoo is an expert in industrial robotics, PLC, machine vision, operating system, information technology, and many more. And two of his publications titled Edible Bird Nest Processing Using Machine Vision and Robotic Arms and Adaptive Phototransistor Sensor for Line Finding are published in Scopus and Science Direct. Mr. S. Yuvarajoo is our second speaker for today's webinar. Good morning, and how are you, Mr. Yuva?
Good morning. I'm fine, Mr. Fahrul.
Good.
Thank you.
Thank you. Ladies and gentlemen, before we begin exploring the evolution and experience the robotic automation projects, I wish to inform the participants to post your questions at the question section in the control panel on your device in order to ensure the smooth flow of our webinar session today. If you, however, would like to speak to or deliver your question personally to the presenter, you may do so at the end of the session after both speakers has completed their session. The question posted will be answered within this session, depending on the need, suitability, and time factors. And if the time does not permit for the question to be answered within this webinar session, the presenter will later may choose to respond them via email or WhatsApp. Without further ado, I would like to begin our session with the presentation from our first speaker, Mr. Shafeek Ahmad Mustafa. Please. Maybe you need to on the mic.
Right. So unmuted. Sorry, I've been muted by organizers just now. Right, let me share my screen. Okay, hopefully everyone can have a vision on my screen. So Assalamualaikum and very good morning to everyone, and thank you so much for inviting us today. So first of all, MPC, MARii and also GMI. We'd like to really thank you for inviting us as a speaker. So today we are going to talk about industrial robotic arms. So it will be a basic introduction on what are the robots are and everything. So we are going to go, without further ado, I'll go into the next slide. So this is the future of manufacturing, where we are looking in a lot of robots are working maybe around with humans and autonomously doing all the jobs in the manufacturing facilities. And we have been talking about smart manufacturing for a few years right now. So if you see, most of the things that are done here is using a robot, a kind of robot. Maybe it's a mobile robot, unmanned aerial vehicle, or maybe it's a robotic arm. So what we are going to talk about today will be mostly on industrial robot. So these are my content. I'll be presenting from what are the and why do we need industrial robots, then the classification and types of robot, industrial robotic system. When we see we want to implement a robot, what are the things that are needed to implement the robot in a facility, and then some sample application and how to choose a robot. And then also we are going to talk about robot architecture, communication, and also connectivity. And this one will be presented by my colleague Yuvarajoo later. So let's go into this. What is the industrial robot? It's an automatically controlled, programmable, multi-purpose manipulator and programmable in 3 or more axes, and also used in industrial automation applications. So if you have 5 of these criteria is met, it's an industrial robot. Because robot, we have a lot of division. We have a service robot, we have unmanned aerial vehicle, we have automated guided vehicle as a robot. So this is, we'll be focusing on the industrial robot itself. Why we want to implement robot? So there are a lot of reasons, but I can, in summary, we can summarize as to increase productivity, quality, and then increase safety, and also to reduce cost. So of course, if you know that a robot can work around the clock, so it can work in higher precision or accuracy manner, and also in some cases we use it as a safety. I mean, like a welding application or something. So we need a really minimum human intervention in that. So that's why we have to implement the robots. So these are the classification of industrial robots. It is classified by the mechanical structure of the robot. So if we can go from the first, it is a linear robot, which consists of linear mechanism on each axis. So basically, we can configure this into 3 axes or more. So it will just move in a linear style. Sometimes we call this robot as a Cartesian robot. And then we have SCARA robots on the next. So the SCARA robots are selective compliance assembly robotic arm. So it can move in certain degrees. So that's why we call it a selective compliance. So it's really high speed and high accuracy. But of course, it depends on the application where we can use this with certain degree of freedom. And then next we have articulated robots, maybe mostly known as a arm. I mean, arm type. You can see there's about 4 degree of freedom to 6 degree of freedom. So this robot is quite flexible and it can reach almost a bigger area than other robots because of the width. And then next we can see the cylindrical robots. This type of robot are specially used for handling purpose. So it will move in cylindrical manner. Maybe depends, minimum it should have about 4 axes or more. And then we have also parallel robots. It's also divided as a delta, or maybe we can call it as a, some of the manufacturers call it as a spider robot. So these robots are really fast, even though it's low accuracy, but it's really fast and high speed. So it's mostly used in high speed applications, such as in conveyor, food industry conveyors, and something like that. So we will go to next video, which we can see the application. I mean, how does the robot move? So this is a linear robot, linear type. So if you can see, there's a 3 axis and you just move within the X, Y, and Z environment. And this one is a SCARA. You can see how fast it is. It can reach up to 6 meters per second and even more. And the accuracy can go up to 20 micron easily. So these are used really in a high speed applications. So we have a different models. I mean, you can choose the reach and areas. This example of a cylindrical robot. you can see how does it move. So it's just move in a cylindrical manner, up and down, and also rotating the center axis. And this one will be parallel or delta configuration. So these robots are really fast, because how they build that is in a kind of really fast and also quite high accuracy. It can go up to 0.1 mm. Right, next, this is articulated robot. So normally we will see this type of robots in industries because of its flexibility, reachability, and then the payload that it can handle, the degree of freedom that we have. So it has a lot of, payload variance. It has a lot of reach areas, right? Okay, next, I would like to introduce that there's another type of industrial robot. We can separate into two currently. We have a traditional industrial robot and also collaborative industrial robot. So whereby collaborative industrial robot, it can work with human. That's why it's called collaborative. It is safe to work with human, but of course there is a plus and minus in both type of industrial robot. So if you see the traditional robot, we need an enclosed cell. While the collaborative robot, you don't need it. You can just work with human in a safe manner. But on the industrial robot, traditional robot, we have higher payload or higher speed and accuracy. So it's vice versa on the cobot. And then also traditional robots, normally it has a complex programming, but they are improving. There is a lot of simplified program structure and teaching are coming out. On the collaborative robot, on the other hand, they have lightweight design, a simple system that is easy to deploy. So I'll show you a video where you can understand what is a cobot is about. So this is an example of cobot. This is from Universal Robot. They are really flexible, lightweight, and also there's a lot of advantage on top of the traditional robot, beside the accuracy and also the speed. So you have like a really flexible arm that it can turn 360 degree plus minus in each direction. The programming cycle also is quite easy, and for new people to learn it is quite fast, what we can say. So something like this is an intuitive touch panel, and then you can just teach it accordingly. So people with minimum technical knowledge can start away using the robot out of the box. So this is where the robot industry is going on. I mean, we don't need that complex type of configuration, but of course it depends on the application later. And one of the top notch of this robot is actually it's safe to work with human because it will stop when there's a disturbance from outside. So let's say it hit human or something, it will stop, and then we can resume back safely. And there's an advanced force control on this. So this is where it's enabled that feature. I mean, when it touch people, hit people, it can stop in a way. All right, next we will talk about industrial robotic system. When we want to implement a robotic system, right, we have a supportive elements that, it's not only the robot itself. You must have that gripper or something. So this is where I conclude what are the things that are needed. So I'll put it into two ways. One is internal and another one is external. So what we are looking here is actually the internal things that we are needed on the robot, which will be mounted directly on the robot most of the time. So we have application tooling. It depends on the application. Let's say you need a gripper or vacuum to pick apart. So this is mostly for part handling. And then you might have a welding tool, rotary tool, let's say grinding or screw driving, buffing. And maybe in some cases you need a special like a spraying tool to be mounted on the robot. On top of that, you also need a sensors to support the application. So we have different sensors: photoelectric, ultrasonic, laser sensors, and maybe LVDTs for to check like accuracy checking or something like that. And then most of the system right now for robot is vision guided. Why we need vision? Because we need it to have some autonomous decision making, or maybe we want to align some part using the camera, so it can have that vision, machine vision, to detect and then request the robot to do. So all these are internal equipment that can be mounted on the robot. We also have external equipment to support the process. So such as additional equipment that we need, like conveyors, jigs and futures, and then maybe vibrating bowl, stackers to handle the tray in and out, and maybe some external tooling and also a camera to support from outside. where the robot bring the part to check on the camera or something. Then external axis, we also need like let's say additional axis. Let's say you need that robot to move further to handle parts, so we might need additional axis. And in some cases like CNC machine, maybe a 3D printing or something like that, we need the external axis to handle the part where the robot will be static, but you have external axis, the 7 axis or 8 axis to control the parts that you're handling. And finally, we have a robotic cell, or we call it safeguarding, maybe a cage to safeguard your application. But this is all depends on your application. So my collaborative robot might not need this caging, but industrial robot, of course, they need the area, special area where you have to separate the process from human intervention. Okay, next we are going to see about application. So if you see this chart, right, from World Robotic 2020 survey, the most application on the industry by using a robot is used for handling parts. So handling parts can go up to like pick and place, machine tending, palletizing, or maybe packaging. So it just do like pick and place application. Next will be a welding. So this is a well-known application where most of the automotive industry is using. So to weld the car parts, doors, something like that. And then assembling. So on the assembling side, we can use a robot to just assemble a part into a semi-finished product or maybe finished product. So the robot can just assemble and check every part of it before it become a final product. And then clean room application mostly is used in the wafer or clean room type applications. So still robot, but it needs a special robots. And then we have also dispensing, to dispense liquid, to dispense glue, maybe spraying, all under that, and then some processing like buffing and other unspecified processes. So these are the main processes that we are looking into this, when we want to use a robot currently. So how to choose a robot? Here I'll just put a simple guideline from our perspective, how to choose a robot. So first you need to check on the payload, on the end effector and the workpiece. So how much is your weight that you're going to carry? What type of end effector? Is it welding, buffing, or just a simple gripper for pick and place? And then reach, we need to know how far that the robot need to reach, or in what degree of freedom that it should work. You know, something like if you need a 6-axis to a complex motion, so you need a 6-axis robot. Next is the speed and repeatability. In most cases, we really need a high accuracy robot for, like, say, pick and place, inserting or something like that. So you need to go to high accuracy. And in some cases, you need a high speed, like in packaging industry, food industry, you need a really high speed robot. And then next, you have to, after you finalize all this, you have to look into what type of robot is suitable for your application. So whether it's a linear, cylindrical, or articulated, from this classification of the robot, or you need a traditional or collaborative type, whether it's working with human or just working separately. So you can choose from that. And then finally, we have also another division where you have a special needs. Let's say you need a high temperature, explosion proof or clean room type of robot. Then maybe the mounting type. Are you going to mount it on ceiling or from wall or floor mounted? So you have to have all this before you can choose a correct robot for your application. So from by that, I finished my presentation. So I'll pass back to Encik Fahrul. Thank you so much.
Okay, thank you, Mr. Shafeek. All right. It is a very good insight on the types and functions, of industrial robots. I noticed that there are some terms that has been used during the presentation, like collaborative robot or cobot, right? And you have also mentioned the applications on some of these robot, but in particular, perhaps maybe you can elaborate a little bit on the specific function and application of the cobot itself, the collaborative robot, because it collaborates with the presence of human. So in the industry, normally, where does it apply to?
Right. So in industry, some of the application you need to work alongside human. I mean, not most, but currently we are actually engaging a lot more application for the robot to work with human. So let's say human will do something, some assemblies with the parts alongside the robot that will assemble something that's really niche or maybe high accuracy things. So by that time, you don't need to separate the robot application and also human. So you can just put a human on one side and the robot on the opposite, and it will work alongside human. So that's where this collaborative robot is applicable. According to the guideline, you have some phase like it's like level 1 until level 5, where how much is the integration with the robot. So we have to go through that to implement this. So if I can give you some example, there's a case where in a for car factory, the people, I mean, they will handle a glass for a car. They will put on top of the car. So before they need to put on top of the car, they need robot to apply a glue. So what they will do, they'll just pick that glass and put into a jig and fixture and wait for the robot to dispense. So without any, what we call that, any guarding or something. So you just put that and then wait for the robot to apply and pick and paste on top of the car, something like that.
All right. Thank you very much, Mr. Shafeek, for the very insightful presentation. We have some questions from the audience, but looking at the agency of the question, I think maybe we will answer it at the end of our webinar session today. So our next presenter, Mr. Yuvarajoo, is ready with his slide. Then let us pass the presentation to Mr. Yuvarajoo to present on his slides. Please.
Thank you, Mr. Fahrul. Okay, good morning, everyone. Okay, my name is Yuva. So my colleague have presented on the mechanical and selection of the robot. So right now we will proceed with on the more to technical or the systems of the robot. Okay, so the first thing is how's the robot architecture looks like. So whenever you buy a robot, it comes with a very bare structure. Okay, means it comes with just very bare robot, no end effector and no base kind of thing. And it comes with a controller, and nowadays they are optional for teaching pendant and so on. Okay, so the external equipments or all those items need to be done according to what my colleague shared. You need to have an internal or external supporting mechanisms. Okay, so how is really a robot architecture looks like? So basically the main brain of this robot is the robot controller. Okay, it's running on a certain kind of OS proprietary to the company providing, and then it connects directly to the robot. And robot is basically driven by servos. It can be 5-6 axis, 4 axis, or it can be the categories like what my colleague mentioned. Okay, then additionally it comes with teach pendant. It can be intuitive teach pendant, or it can be a normal joystick kind of teach pendant. And the latest generation, there's an optional for teach pendant whereby you can run from the computer software itself. Okay, so means you just connect to any computer, you just install the software, you can just communicate with the controller. And additional to that, you have an option to buy software such as simulation softwares, or maybe designing software. You can teach everything inside the software and upload to the controller to run automatically. And plus there are also application specific toolings or external equipment sold by the manufacturer itself, such as maybe a gripping unit, a vision system unit, conveyor unit. Is a standard plug and play modules. You have an option to choose that particular part. And also there are communications available. So most of the robot controller comes with a standard 1 or 2 protocol of communication plus some IOs. So you still have the option to select in more what we can say optional communication methods such as Ethercare and so on to communicate with your controller. And also we have there are accessories such as we call it like calibration window, teaching pen or something like that. Okay, so this particular architecture is actually comes from Denso, and it's almost like similar to almost all the manufacturers. Okay, so how's the robot teaching actually looks like? Okay, So nowadays the robot teaching actually getting more and more easier. Okay, not only a collaborative robot, even industrial robot, new generations which are launched in 2021 comes with more intuitive teaching. Okay, graphical based teaching and guided teaching where you just drag the robot, and it's getting more user friendly. Okay, you just put in two buttons, pull or move the robot, teach 2 points, and you're already ready to run. Okay, there's no special education needed. Okay, then you just play back, the robot will start to play. Simple as that. Okay, so this is the latest generation of robot. You can expect this revolution in the standard industrial robot in near time soon. Okay, so next is what are the robot arm application key add-ons? Means summarizing from whatever Mr. Shafeek mentioned, what are the key add-ons most commonly applied even through our experience. The first thing is sensors. Okay, sensor is basic sensor like detection, colors, distance, measurement, and so on. Okay, then it comes the next important thing is machine vision system. Okay, this is one a very important topic. 90% of the applications we are implementing to customers contains vision system. Okay, because it makes the entire robot operation more easier and more accurate, and we can do a quality inspection at the same time. So it's like all in one. Okay, and additionally we have code sensors. Okay, this code sensor can be used for traceability. Okay, such as MES system and so on. We can get the feedback from the part, the barcodes or QR code, and then feedback, and we send to your MES system or ERP system. We get a feedback that whether we should proceed with this part or there's a pending operation which is being skipped by the operator and so on. So this way we can do a very good traceability before robot starts operation. And finally is the actuators. Okay, so these are four key components we apply in 90% of the applications. So how do we really achieve this? Okay, so the important part of entire automation is actually connectivity. Okay, so when you have one robot, you are connecting with like PLCs, IO, vision system, and so on. But when you have multiple robots, you need a real-time deterministic Ethernet connection. Okay, so there are basically two types of communication. One is data-based communication. Second is IO-based communication. In conventional, normally we use IO, which is on and off. But when coming to future-proof or expansion of the system, okay, let's say you put a one robot right now. Later you want to put second robot, third robot. Then you want to communicate everything together. When you use IO-based communication, you can't exchange much of the data. For example, you want to send, okay, I've done this number of quantity. So when you use IO-based, it's very hard to transfer these numbers. Okay, you can do a very basic, simple communication only. But when it comes to the data-based communication, you have the flexibility to change any data anytime, and also you can do a data collection, and most important part, easier for troubleshooting plus preventive maintenance. Okay, so on the right side top you can see the type of common communications available in the world. Okay, so these are the market share of the communication field bus, we call it. So such as like Ethernet IP, EtherCATs are the most common names, and I think the older technologies like Modbus, even the Modbus has been upgraded, and there are new technologies coming in such as OPC UA over TSN. All these are giving a data communication methods. Okay, so what we really trying to achieve with all this data? Okay, so whenever we are looking at Industrial Automation 4.0, we need actually data to process. So on your left side, you can see the conventional manufacturing system. Okay, it's based on human observation and then based on human experience to make a decision how to improvise the system, and then we use human intelligence to change the way how the machine operates, or how to optimize all those things. But nowadays there are new systems, okay, where we need sensors. Okay, we need a lot of feedback from the robotic system. We collect the data and we feed it through machine intelligence such as machine learning, artificial intelligence, and we are making smart decision. Okay, such a system like I mentioned earlier in the video, where we collect the data, and then whenever there's an end of the operation, quality failure, the system automatically manufactures additional parts. And there are new systems such as robot part optimization. Okay, when it starts to collect the data, it's actually make a decision how to optimize the robot movement path. Okay, this can actually improve the overall performance of the system. Okay, such data collections is common names like MES, IoT, conventional ways like Excel, and then SQL is the backbone for most of the database operations. Okay, so as everybody know, so I just like to highlight how's the fourth industrial revolution which is going on right now. We need more data from the robotic operation to optimize the every production operation. Okay, this is just a graphical view. Okay, this is one of the example we did for customer. Okay, actually this is one particular dashboard for one robot only. So it's actually consists of multiple robots and all those things, but this is concentrating one robot to actually visualize how's the robot utilization. Okay, so in your fingertips, anytime, real time, you actually can get the robot information such as OEE, how's your efficiency, availability. Okay, if you notice, in this current window, we can see availability is 100%, means the robot is not operating at all, it's idling. So whenever the management or operation team sees this thing, they're able to rectify immediately. Okay, why there's a stoppage on the line. Okay, rather than there's a line visiting every 5 minutes, 10 minutes, and so on. This can give you a real-time performance analysis. Okay, so basically in industrial automation and robotics, we can assess the readiness of a certain particular company in a list of ways. Okay, so this list actually created based on our field study or our experience on implementing robotics and automation to our customers. So the first thing when we go into the company, we evaluate the automation process, how well their process has been automated. Okay, what can be done to improve their automation process. Okay, such as like they have maybe have individual machines in a line. Okay, how we can connect it together. Second is where we can include the robotic technology, because a lot of component handling it's been done by human. Okay, to improve this, we will introduce the robotic technology such as maybe packing, pick and place, loading, unloading. They are the most common applications for robotics, other than the precision automations. Then the next part, we are looking into sensor or vision feedback. This is very important for autonomous operation. Okay, so wherever needed, we use a vision feedback or sensor feedback to give more insights to the robot. Okay, to make a good decision. Okay, next part will be data-driven process automation. Means how we can communicate, in a line or in an entire production line, how to communicate with each other. Maybe the customer have a already predefined process, but they're running an old PLC systems. So what we'll do, we'll go in, we'll add in a card or we add in an additional system where we can collect the data from the existing PLCs. And then with these communication methods, we will prepare the entire architecture for the data-driven process communication using Ethercat, Ethernet IP, and so on, where the connectivity comes in. Okay, this connectivity depends on your manufacturing or the brands used. For example, you are using Rockwell or Mitsubishi, Omron. Every particular company, they have their specific set of communication methods. So when we go in and evaluate, then we select the protocol communication accordingly with minimal costs, because when you are doing the entire protocol communication, is the cost is quite high. So we will look into the more effective way of doing the communication. And next is data collection. Okay, we need a storage space for data collection. We call it a database. So we will advise on how to establish a database to collect all the process data into a storage. Then comes in the IoT, where the visualization. So IoT platform will provide communication between your hardware to your database, or even from your database, you'll do a visualization and show some data such as OEE, readiness, and so on. And next, this is a coming future, or even right now is happening. We call it machine learning. So machine learning, we feed in all this data, and the systems comes with its decision or recommendations on how to improvise your systems. And then finally, the artificial intelligence. This will be the ultimate aim for everyone, where an AI operated factory, okay, A to Z of the process, fully automated and controlled by this intelligence. So it's going to happen soon or later. Okay, so these are the list of readiness we assess with customer. Okay, so basically this chart here actually shows the, how we can create the value creation in automation. Okay, so with robotics and sensor alone, we won't create the entire value creation. We need to include the cloud and AI, intelligence, everything to come with the entire value creation of the entire automation sector. Okay, so it's just a rough robot evolution. Okay, so finally, before ending my slide, so whatever we have presented over here is actually just a brief introduction of our robotics and how's the implementation. So you may contact us further through these links here to find out more details of your application. Maybe you have problems or improvement you would like to do. You can contact us. We can come and advise you in detail on how it can be done, or how we can exchange knowledge. Okay. And additionally, I'd like to thank MPC, GMI, and MARii for organizing this webinar session and giving us opportunity to provide the webinar. Thank you very much. I'll pass back to Mr. Fahrul.
Okay, thank you, Mr. Yuvarajoo, for the very insightful presentation earlier. Well, we have several questions from the audience. Let me. Okay. All right. One question from the audience. I think was it Mr. Abdul? How do we? Can you see my screen? Yeah. All right. One of the audience is asking for the background of the moderator. Okay, my name is Fahrul Rizal Halim. I'm the head of section for marketing and corporate communication of German-Malaysian Institute, GMI. Some background of what GMI or German-Malaysian Institute is all about. We are a training academy, a training institutions, producing graduates in the field of engineering and technology. Some of the programs that we offer in GMI are foundation programs on the German preparatory program, as well as GMI UTP, University Technology Petronas Foundation Program. We have some 19 Diploma of Engineering Technology of our academic program. We provide some project consultancy and short courses, as well as a competency program, certification, accreditation by several agencies and bodies like SEDA, Cisco, the MARii, Andres and Hauser, and several others. A specific program that we conducted with the Malaysian-German Chamber of Commerce are the German dual vocational training, mainly in the area of mechatronics, industrial management, as well as logistic management. All right. That is a little bit about myself and GMI as a whole. All right. So we also have a question from Madam Tan Yet Mi, asking on advice and video of the presentation today. I've been informed by the organizer, Malaysian Productivity Committee Corporation, is that the videos of today's webinar session will be posted later in the MPC Facebook. So you can browse through MPC Facebook page and download the video of this of today's webinar in the Facebook. All right, a question by Mr. Jekmi Chua. He asking about the what is the maximum weight that a robot can lift. I believe this question are posted to Mr. Shafeek, as his presentation earlier are more to mechanical and selection of industrial robots. Then perhaps Mr. Shafeek can answer this question.
Basically, there's a really vast range of payload that a robot can handle, and also it limited by the design of the robot or the maker. We can have as small as 500 grams up to tons, to lift tons of payload. So it didn't actually stop at some point. So we know that there's a 2-ton robot, there's a robot that can even lift up to 10 ton. So it depends on the application.
Is the weight is the main criteria of selecting the robots to be used?
Okay, the payload is just one of the criteria. As we shared before, we have about a few criteria that you need to meet, because we still need to know how much is the reach, how complex is the part that we are handling, the part, so-called the reach that we are needed, and then maybe the type of application, because see, some applications you just need to pick and place on a flat surface. So you don't need to go up to a 6-axis robot, something like that. So you can be done by a linear robot or maybe a SCARA robot. So if you need a high-speed application, then you have to go for SCARA types, SCARA robot type, because it is really high speed and also high accuracy application. So it's mainly depends on the application. So we have to go to study the whole application first before we can conclude that these are the suitable robot. So there's a lot of criteria. And also in some cases that we have seen, some companies, right, they are really mixed production, where maybe they are running this part only for 6 months, and then the next month, the next quarter, they will change the part. So for this type of company, they can use the 6-axis robot, which are better because you can just reprogram it to do different tasks easily, rather than you fix with the linear robot or something like that. Because linear robot, there's a limitation, while 6-axis robot, it can do much more. So after 6 months or 3 months of your developing this, maybe assembly this product, and then you have a new product coming in, you can just reprogram the robot, change the end effector, and use. So it all depends on your application.
I see. Okay, thank you, Mr. Shafeek. Our next question by Mr. Zainuddin bin Jusso. I believe this question is meant for Mr. Yuvarajoo. Let me read it. Hi panel, it is seemed that the content of this webinar is more focused on traditional application of the robotic application, particularly in the manufacturing and automotive industry. Is there any example of the robotic application in the non-traditional application, such as construction or oil and gas, or is there any effort towards such application? So perhaps the second presenter, Mr. Yuvarajoo, can elaborate on this?
Okay, basically robots we can consider as a very vast field. Okay, so robots are not considered not only the 6-axis robot or 4-axis or SCARA robot. Okay, actually it consists of mobile robots, autonomous moving robots. Even at one point of time, drone is considered a robot as well. Okay, so in such as a construction field, there are robots being applied to do like wall plastering, automated wall plastering using 6-axis industrial robot, with joined together with mobile robots, where it moves and it goes on doing the construction. And the latest technology will be using 6-axis robot to do 3D printing of the houses, construction materials, and so on. In oil and gas, this 6-axis and industrial robot also being applied in oil and gas. Okay, but the robot must come with there's a particular certification such as ATEX, which is explosion proof. Okay, so this kind of application still being implemented in oil and gas, but it depends on what kind of application they are particularly looking at. Okay, it might be related to oil and gas parts production facility, or is it really on oil and gas platform? Okay, I think there are new robots such as Spot Mini is being used on the oil and gas offshore fields, where it can move and do the operations and so on. Okay, so if you are talking about the robotic field, then there are different type of robots can be used, not only the 6-axis industrial robot. But from our knowledge, the 6-axis, 4-axis, or any type of robot can be used in any field, and there's already application around it. Just it depends on what kind of certification required for each particular field. Okay, I hope this answers the question.
Okay, all right. Thank you, Mr. Yuva. All right. Next question we have from Mr. Tan Moon Wei. His question is, what kind of vision system using on cobot, the cooperative robot? And maybe I think this Mr. Yuva would like to answer this vision system.
Sure. Okay. So okay, vision system, there's a lot of types. Okay, we call it either vision sensor or vision system. Okay, vision sensor, basically we just teach the vision sensor to make a decision such as pass fail according to the color, shape detection, size detection. It just gives a pass and fail only. Vision system is more advanced than that, and it has more tools inside it for object recognition, measurement and tool orientation, all those things, and it gives the data as output. Okay, so there's two type of vision. And vision, there's a lot of different brands, okay, in markets such as Cognex, Keyence, Halcon, SIG, almost any of the sensor brands they have a vision system. Okay, because it comes a very preset of tools which we can use, such as, like I mentioned, measurement, object recognition, all those things. Okay, as for the robots, actually robots comes with just a bare robot. There are one of two type of robots, they come with built-in vision, but those are very basic visions. Okay, so most of the application we are doing for customers, we always use the external vision. Okay, because when you're putting a vision on the tool itself, there are some advantages and disadvantages. Okay, for example, you want to have a good cycle time. If you mount the vision on the robot, you have to take a picture before and a process before you're picking the part. But if, let's say, you're putting a stationary vision while the robot is moving, another picture taken and the decision has been made. So it's increasing your cycle time output. So the decision of what kind of vision application depends on your process. Then we make the decision accordingly. And most of the vision system able to do most of the process. Okay, it depends on what kind of brand you are like, or we'll recommend our our preferred brands and so on. And additionally, the new tradition or new technologies will be AI. They already implemented machine learning inside vision system, where you can, like, for example, you have 100 defective parts and 100 good parts. We just put all these images into this training vision, and then after that it makes its own decision. Okay, for example, maybe you're talking about glove industry. Okay, the glove rejections. Okay, we can feed in the good and bad parts, then you'll start to have an automated process of rejecting the gloves and so on. Okay, so these are the things, but as I mentioned, the vision can be very flexible. Okay, and it is suited according to the application. Okay, and there's from low cost and up to high cost as well. Okay, so we normally for vision system, we grab the part or application or the idea from the customer, and we go and do a case study or maybe test a sample in order to give an answer on what kind of vision system need to be used. Okay, like I mentioned, the brands, there's a lot of brands you can use, but at the end of the day is what's your cost, okay, and also what kind of detection you like to do. Then we'll recommend accordingly. Thank you.
Okay, thank you, Mr. Yuva. There's also a question from Mr. Arif Daniel. Will this recording be available online? Yes, it will be, as I explained, it will be posted in MPC Facebook page later after the event ended. You may go to MPC Facebook and view or download the videos of today's presentation there. Yeah, we have time to go to another question by Mr. Meng Seng Chai. So his question is, do we need a special computer to run AI or machine learning software?
Okay, I believe I can.
You did mention about machine learning, yeah, in your presentation. Okay. Yeah, maybe you can answer this.
Sure. Okay, basically, it depends on the, like I mentioned, the amount of data we're going to process, type of data. But most of the machine learnings is well known to run good in GPU, graphical processing unit, compared to CPU. Okay, because GPU contain more processing unit compared to CPU. CPU, there's a special task for it, but GPU has another special task, but it's more efficient in doing the machine learning, such as you can see latest like NVIDIA, or one of the famous brand where they produce these AI machines, okay, such as Tegra, all those compute modules. And most of these AI being trained on GPU because it will be much faster compared to CPU. Okay, but you have to understand CPU and GPU have both different tasks. Okay, but GPU is more optimized to do this AI tasks. Okay, at the same time also, if you want to do image-based AI training, it's more focused on GPU. So traditional industrial machines on the field, it's more focused on CPU. Okay, it doesn't have GPU unit. So for when we're coming to AI and machine learning, we'll be adding a graphical processing unit, GPU card, to these standard industrial machines. Okay, in order to give the capability to process the AI. Okay, but I need to mention here, the AI can be run in CPU as well, but the speed will be slower. Okay, because the GPU can be accelerate the entire learning process and also decision making. Okay, that's why the GPU is more preferred. Okay, I hope this answers the question. But as you know that GPU prices are nowadays is not very cheap, so it can cost you higher or lower depending on the scale of AI application you are looking at.
Yes. Those people mining Bitcoin may know the power of a GPU.
Sorry, Mr. Fahrul, just to add in a little bit more thing. Actually, there's a new AI processing unit being included in new CPUs. Actually, even in your phone, you can. There are new AI chips introduced, but it's doing a small scale of AI things on your phone or even in your CPU. But it's coming new technology on that. They call it like neural unit or something like that. No? You might have heard about it, like Qualcomm or Huawei Silicon. They include a neural unit, NPU, or something like that.
And that is also part of machine learning, I believe.
Yeah, correct.
All right. I think we have maybe a little bit time to answer another question by Mr. Muhammad Nuraiman Hakim. Is cobot widely used in industries, especially locally in Malaysia? So maybe Mr. Shafeek can answer this question.
Right. So compared to traditional industrial robot, of course, because traditional industrial robot already being implemented a long time ago. So I think the portion, let's say, is maybe take up about 5% of 100% of the implementation for now, currently cobot, but it's actually going up. So the cobot is actually what we call that, it's rising right now because more people get to know and more application is being deployed with the industrial robot, collaborative industrial robot. And in fact, in Malaysia, during 2014, we might only have 1 or 2 brands who are using this, who was in Malaysia for industrial robot, but currently we can at least 10. We can point out at least 10 collaborative robot which are stationed in Malaysia, and they also have their own market and their own customers. For us, because we also experienced it since 2014, there is a lot of company actually have implemented the industrial robot. So the collaborative industrial robot. It depends on the application basically. But whatever the traditional robot, can do, in collaborative robot can do in a certain way. It's not all, but in a certain way. So it depends. Let's say when you come into high-speed application and also high payload, you still need to go back to the traditional robot, and not the collaborative robot. Because collaborative robots still they are coming out with a lot of new functions, new algorithms or sensors to make it collaborative, but it's still quite new, and it's growing exponentially, I can say.
Okay, all right. Thank you, Mr. Shafeek. I'm afraid that we are short of time, as it now has reached 11:30, the end of our webinar session. One of the questions posted by Mr. Y. Yap, does GMI offer robotic course? If yes, who to contact? So yes, we do provide courses in terms of short courses as well as customized courses. The numbers as per displayed in the screen. Yeah. The rest of the questions, we are sorry, we are unable to answer them during this webinar session, but we will answer your questions and post it back to you later via email or WhatsApp. And the Secretariat has already informed me that MPC Secretariat will email the slides and video link to all attendees today for today's presentation, our webinar on industrial robotics. With that, I would like to thank you everyone for participating in this webinar. Especially thank you to MPC for giving us the opportunity in joint organizing this event, webinar on industrial robotics. I would like to personally thank the CuberLab Sdn Bhd as well as MARii in partnering with GMI and MPC in organizing this wonderful webinar series event. Yeah. All right. Thank you everyone for attending. And we will have to end our session for today. All right. Thank you.
Thank you so much.
Thank you so much.
Have a good day.